Hi, this is Rubas Khan, and I'm here with the intention of making another video series, and this time on understanding how recursion works with binary trees. By now, you already know what a binary tree is, but we often fail to grasp the question why recursion is used on tree operations. Well, in this video series, I'll try to answer the question. So let's get started. So you are given a tree, and you're asked to find, or you're asked to paint each node of the tree. But the restriction is to move from one node to another, you need to strictly use the edges. What I mean by this is, in order to move from A to B, I have to use this edge. Similarly, to move from A to C or C to F or C to G or B to D, we can only use the edges. We cannot move from B to C directly because there is no direct connection between these two nodes. If you have to go from B to C, the only way is to go to A first and then from A to C. Now let us start painting from the first node of the tree, which is the root. And let's give it a color. Let's say red. Now from A, I can move to either B or C. But as I'm one person, I cannot go to two places at the same time. Your computer is working in the same way. It must go to either B or C. So let's choose B. So from A, using this edge, we move to B. And after reaching B, let's do the exact same thing as I did in A, and that is color it, and again, move to the left. From B, I could have moved to D or E, but as I've went to the left from A, I have to maintain that movement. So I am moving from B to D, not E. And let's give D a color, and that's red. Now D does not have any children. So what we can do is we can go back to B and then again move to the right of B, and that's E. Again, give E a color, and as E does not have any children, we move back to B. We are done with B and its children, so we move back to A, and then we start going to the right. We reach C, do the exact same thing as we did on every node, and that is give it a color, and then first move left, give it a color. As F does not have any children, we go back and then move to the right, give this a color. And again, as G does not have any children, we go back, and as we are done with C and its children, we go back to A. And that's it, we are done painting. Now let us summarize the whole scenario. I had a task, and that is to paint every node of the given tree. So we can write paint, and we were given a tree. Let's denote it with a capital T. And as we started from a root, as we started from a node, and that's the root, let's say n is the node. So this was n initially, the root. Then what we did was we gave this particular node a color, color the node n, and then we moved to the left child of n. If you remember, we started from A and then we moved to the left child of A. So what we did was we moved to the left child of this node n. And once we moved to this node over here, we did the exact same thing. That is paint. So the exact same thing means give it a color and move to the left. So when we reached the last node over here, D, we went back and then from B we moved to the right child. So after we were done painting the left child, we moved to the right child. So we can say we left, sorry, we moved right after moving left. So let's say off N, and did the same thing again, and that's paint. Okay, so if you remember, when we moved right, we again did the exact same things that we did on the rest of the nodes. Well, do you see what's happening? We are applying the same job, paint, like a loop. In other words, we can say that the task paint is reoccurring at every node. This reoccurring of a task is known as recursion.